Okay, naming epoxides is not a huge part of this chapter. It's only one page and it's in the textbook. And it's very complicated because there's three different ways that you can name an epoxide, okay? The first way is to name it from an alkene. The second way is to name it as an epoxy compound. And the third way is to name it as an oxirane. So let's go through these various methods. Now, if you have a carbon-carbon double bond in molecules like ethylene or propylene, you can oxidize these substances and convert them to the epoxide, as we'll see later on. And one of the simple ways to name these epoxides is to name them as a substituent of an alkene. So basically, we're indicating how it was made. This is called ethylene oxide, okay? So that's the way you would name this three-membered ring or cyclic ether with three total carbons in it in a ring. Propylene can react with similar reagents to form propylene oxide. So you can see how the name comes about. It comes about by the alkene, and then it's very strange, but the ending of this name is going to be oxide. So if you see an ending oxide, that means that you're going to have a epoxide to think about, okay? Now, if you have a six-membered ring, let's say, that also can form epoxides, and this is going to be a cis-fused bicyclic substance, but I won't show stereochemistry, but we could just call this cyclohexene oxide, okay? So if you have a really, really simple epoxide and you can definitely see what alkene it came from and name the alkene, then you just name the alkene and tack on oxide and you got the name and you're done. Now let's talk about method 2, which is to name it as an epoxy. Okay, name it as an epoxy. Now if you have something like this, okay, there's quite a few carbons here in the longest chain, and there's our epoxide there in the middle of the molecule. So you'll want to count this out, okay? And you will want to indicate numbers, two numbers where that oxygen is bonded. So the oxygen is bonded to carbon 3, and the oxygen is bonded to carbon 4, and we insert the word epoxy, okay, epoxy, and then the ending of the name is just the parent chain here that we have, okay? So that's just going to be hexane, okay? It's slightly more complicated, but if you can't really identify what the simple alkene is that would make this epoxide, you could name it as an epoxy substance, okay? Epoxy is the common word for glue, and yes, glues do sometimes contain epoxide moieties that become polymerized to form the glue upon polymerization reactions. Let's do a couple other ones. All right, so here's a molecule where if we number the longest chain, we can see that it has 5 carbons, but there's this substituent here at carbon 3, okay? So we would want to indicate the position of the methyl group, okay? And then we want to indicate the position of the epoxide. It's between carbons 2 and 3. 2, 3, epoxy. And then the parent chain for 5 carbons is pentane. Okay, so that's a second way to name epoxides. A third way is to name it as an oxirane ring system. And this is perhaps the most complicated, and you might not need to learn this rule even. I think the first 2 rules will help you get started with everything. But if you have a molecule that has a lot of stuff going on in it, Let's just, I don't know, do something like that, okay? If we number the longest chain here, uh, hold on a second. So an oxirane is a three-membered ring. And the most strange thing about this is that for oxiranes, you actually number the oxygen atom as number 1, okay? Which is very weird. So far in this class, up to this point, we've always been numbering carbon atoms as 1, 2, 3, and so on. The chlorines and bromines and oxygens and nitrogens were substituents and were not numbered. Here, you actually number the oxygen atom that's part of that epoxide ring system as carbon number 1, okay, which is very strange. So let me make this molecule a little bit simpler so we won't have to debate numberings. Okay, so if we want to number this, we would number the oxygen number 1, and then number 2 would be over here to the right because it contains two substituents. There's a bromo and a methyl group, and this just contains a propyl group, okay? So that right there is the oxirane. So that's going to be the parent compound. And now we number and name the substituents and alphabetize them in the name. So we got a bromo, a methyl, and a propyl. And I believe that's alphabetized. So let's stitch together the name. 2 bromo, 2 methyl, 3 propyl, and then we just add the word oxirane at the end of it, okay? So very strange. I think the first way is really easy to call it such and such ene oxide. The second way is a little bit straightforward. You just name it epoxy. And the third way is very strange. Okay, so those are the basic ways to name epoxides. There's 3 different ways. Be somewhat familiar with it, but don't spend too much time, I think, because the textbook only gives 1 page devoted to that. So just kind of have some basic familiarity with some simple epoxides.